Hello everybody, welcome back to my channel. So today we'll be discussing the next part of types of corrosion. That is the type 2, which is differential aeration corrosion. In the previous video, we have discussed differential metal corrosion, where we use two different metals. You can check out that video if you haven't. In a very short time I've covered it. So this also will be covering in a very short time for quick revision. Differential aeration corrosion. The name itself is there. Differential aeration corrosion means difference in concentration of oxygen. So there's two applications of this in our syllabus. One is pitting and the other one is called as waterline corrosion. It can also be called as waterline corrosion and pitting corrosion. So these come under differential aeration corrosion. Now what is happening in differential aeration corrosion is, in differential metal corrosion, we use two metals. Here, one single metal is used. The metal, which is, suppose imagine this is water. I'm just giving an example. So we know that in water there will be less oxygen as compared to the atmosphere, which has more oxygen. The part which has lesser concentration of oxygen will act as the anode. It will undergo oxidation. It will undergo corrosion. The part which has more concentration of oxygen will act as the cathode. It will remain safe. Usually we think opposite, right? More oxygen, so more chances of oxidation, so more corrosion. We think that, but do not think like that. Think it of how I'm saying. Lesser concentration of oxygen means it will act as the anode. Anode will undergo oxidation. Oxidation means and undergo corrosion, which is under the water. Now the differentiation corrosion is based on occurs when the metal is exposed to different concentration of air or oxygen. Now I will explain the first one, that is waterline corrosion. This is same thing what I explained about, that same thing only. So when the metal is in water, near the junction, this is known as line of rust. Line of rust, which is formed in the junction of anode and cathode, submerged part and the not submerged part. It's formed, which is line of rust, or meniscus also you can call. So the part which is under the water is known as the anode. Lesser oxygen concentration, undergoes oxidation, undergoes corrosion. This part acts as the cathode. Above the water, it is going to say safe. Where can you see this? Even in ships, if you see the ship, some part of it will always be underwater. So there you can see this waterline corrosion. So in many other places also you can see the part of the metal is always submerged into water, that acts as the anode. Below the water line, the rust line or corrosion line, it shows that the metal is always under that water. Even in ships we can see, even in water storage steel tanks also, you can understand this waterline corrosion. That's the basic principle. Now if you talk about pitting. So in some industrial areas, what happens is that the pipes are left uncared for years. Think of this as a pipe, okay? It's left uncared for years. Then what happens when some dust gets deposited on this, right? When dust gets deposited on this is dust, okay? So what happens? The layer of the metal which is covered in the dust will have lesser concentration of oxygen compared to the area which is not covered by dust, that will have more concentration of oxygen. The area of the metal which is covered by dust will have lesser concentration of oxygen compared to the other parts. So that part will act as the anode. It will undergo oxidation. It will undergo corrosion. Now that corrosion, what happens? Anode covered with dust. So the depth of the pit starts formation, and the depth of the pit, once it starts formation, the depth of the pit will start increasing. So you can see a little pit formation. So we call it as pitting. Okay. So electrolytes, because of the electrolytes and moisture, the corrosion starts beneath the dust, resulting in a pit. And once the pit is formed, the corrosion progresses rapidly. That is the main part. So this part will act as the anode, and this part will act as the cathode. That part will act as anode, and this all part will act as cathode. This is the anode. Okay, that was the main principle. So very simple, nothing much complex, simple concepts only. So thank you for watching. See you in the next one. Bye bye.